Hello, everyone. Welcome to the class. So today we will talk about how to do further analysis of your sharing, of the code sharing, of the critical section. So what's the critical section? We will talk about. We will check what's the critical section in your program and how to detect it, how to check it. And if we know what's a critical section, then we can further to protect it in the end, like in the futures. Okay, so let's take a look of the source code. So the source code is not so difficult to understand. So the source code try to create a two thread. So you have a two thread T1 and T2. It's a peer thread. Then after you create two thread, you join it, you replan, you're waiting for they finish, then you repeat. Then in this two thread, because each thread, the idea of each thread is just like a do a for loop of CNT plus plus. So when you pass these n iterators, how many iterators into it, it should follow the same iterators. Okay. So for example, if I pass two here, because we pass two to the iterator here, so we should get two CNT plus plus, two CNT plus plus. And because we have two threads, so you got two CNT plus plus. So actually, in the end, you should get four. Okay. So if you pass like a six, you have six here, six here. So in the end, you got 12. So this is the concept of this algorithm. This algorithm is actually just try to times two. So you type anything, you try to type like a times like a product, and the product of it by times it by two. So you should expect the result. When you get the 10,000, you should get to 20,000. Okay, so this is the idea of this code. And if you look at the code, it's just create two threads, and each thread just run a for loop, and inside for loop do a CNT plus plus. So right now, let's look at what's a sharing variable. What's a share variable in this case? First of all, we have a global variable here. So we have a global variable CNT. So of course, CNT is shared. CNT is shared by T1 and T2. Okay, so we know it. And how about another part? Another part we pass the address n iterators. So the address n iterators will reference to this number. So this is also shared. So another one is n iterators. This is also shared. So we know what's a variable share. So let's look at what happens inside here. Inside here, the issue is we create a local variable. So after we create a local variable, even though these can reference to these n iterators is shared, but because we create a local variable, so this number should be assigned to an iterator. This is a local variable for a tree, for a thread. So actually we don't actually change it. And if you look at the code, we after we got this, we never change it. We never change it here. We never change it here. So actually, no matter, even though it's a share, but it's only read by your multiple thread, you never update it. So it won't cause any problem. So so in this case, you don't need to care about this one. So another one you probably need to think about is CNT. CNT here, we only use CNT in one line over the source code, right? So just one line. So after you update, it just finish. Then you go to another line. So in this case, we should not get any trouble about this unintended sharing because we know the CNT just got updated in a for loop. It's just one line of code, so we don't need to worry about it, right? However, the issue is still here. The issue is when we run the program, if we give it 10,000, we got 20,000 sometimes, but sometimes we got a totally different number. Why? Even though we understand the sharing and we check it, but still it cannot give us the expected result. Why? This is just one line, right? Should not have any conflict. Why we get this result? So let's look at a little bit more deeper for this one. Does it's only one line in your system? Do you know that? You don't know. This is one line of source code in C languages. Doesn't mean it's one line of source code in your system, in your machine code. Actually, if we try to like look at what's the assembly code for this one line of source code, you will see something like this. So this one line of source code is separate to these three lines of source code in your assembly. So this is for the head. You can imagine that this part and this part is just like suppose this for loop. So we are not going to talk about details here because it's assembly. But basically the idea of this one is you try to load the data. You load the data CNT, you change the CNT, move to here, move to another registers. Then at the end, you move the register's value back to a CNT. So it's kind of you load the data to register, update register, and put the register back to the address to a CNT. Okay, so actually there's a three line of code, and we can see this is load. You load the data, you update, you change the register, then you store it back. So if you can see, actually in this one line of source code, it's actually contain three lines of source code. You will know there might be some issues here, might be. Okay, so let's look at what happened here. So this is the idea. We try to just change the head, load, CNT, update CNT, store CNT, and tail. We try to use this as H, L, U, C, S, T here. Okay, so let's see the first example. The first example is that, okay, so you have T1, you have T1. The T1 is, is, um, is wake up, like it's awake. And T2 is not. So T2 is not awake, T2 is asleep. So in this case, your process try to run T1. So in the T1, we have CNT equals to 0. So in the T1, it's go to the head, it's go to the load the 0 into the register. So register right now should be equal to 0 here. The register is 0 to here. Then you update it. Then you store it. So when you store it here, you try to put the register's value back to count. Okay. Okay. So in this moment, you just the schedule just change. The schedule just change. In this case, right now the T1 go to sleep, and T2 is just wake up. In this case, the T2 run something. The T2 run ahead. The T2 run a loading, okay? T2 run a loading, so which should be load from 1 to here. So T2 should load. Then it's update to 2. And right now, assume we stop here. We just get stop here. So in this case, this is wake up, T1 wake up, T2 sleep. So we come back to do a T, but T here still just nothing, right? T here should just finish the loop. So it's kind of okay, just finish. So still it's got something like a 2 as a CNT here. Actually the register is 1, but CNT is 2. So because nothing happened here, we did not update. So it does not change. Then this is finished. The T1 is finished. Then we go to the T21 because T1 is finished, so T21 should wake up. Now right now, because the data in your register is still 2, so you update. You update 2, store it back to CNT, so you update CNT to 2, and the end. So in this case, you can see at the end, after two thread, you update the value from 0 to 2. So it's successfully. Okay, it's successfully. So if you know what's the process here, we can try to find a trajectory here. So the first one, the start one, do the head. So this is a T1, this is T1, this is T2. So we try to run this first. Okay, so T1 we go here, T1 we go here, then loading something, then update something, then store something. Then we change to T2. So T2, we run something like here. So T2, we run something. So the trajectory will come here, and it's update. So come here. Then we change back to T1. We change it back to T1 to update this one. So it will go something like this. We update it. So remember, this direction is T1, this direction is T2. Okay, then at the end we got this, and this is the correct trajectory. So this is the correct one. Okay, so we got the trajectory, this successful update. Let's look at another example. So we have another example here. Okay, so this example, the CNT equal to 0 at first. So the first one, the T2 just wake up. So T2 go first. So T2 run this. So it's loading the data. So loading the data 0 will be here. Then it try to update. It's become 1. And in this case, uh, it's just stop here. It's try to stop here. So this is the first step. It's stop here. So which means your process will wake up the T1. So the T1 is wake up and T2 just sleep. Okay, so in this case, now you try to run the head, then you load the data. So when you load the data is from CNT. So you load the data 0 to here. Okay, because you haven't update the CNT. You haven't stored the data. You haven't stored the data from the thread 2 to CNT. So you load the data 0 here. Then you do the update. Okay, you do the update. Then you store the data. Okay, if you store the data, you try to put data back. So right now you update this 1, 2, 1. Then you finish. So this is the second step. So this is the first step. This is second step. It's just like a schedule, just like allow the T1 finish. Then it's come back to T2. So when you come to T2 here, because the data is 1 in register, so it's trying to store 1 back. So after it store 1 back, it's still 1. Then finish. So at the end, after both thread finish, you got the value 1 instead of 2. So this is the wrong result, right? This is wrong. So actually, what happened here? Because you update it, but you haven't stored it, your schedule is changed. Like your schedule changed the thread schedule, change to another thread. So in this case, you got some issue. So let's see what the trajectory look like here. So the first one, we try to load data, and we try to do the head load data and update the data on the T2. So the trajectory will be like this. Load the data, update the data, then finish. Update, but we haven't stored. Let's go here, here, then go here. And we know this is not a good trajectory. This is not good. So if you do a lot of practice, you will figure out which is a critical zone. You will find a lot of trajectory. Some trajectory is good, some trajectory is fine. For example, if you do more example, you will find this trajectory is also good one, and this trajectory is not good. So if you do a lot of this trajectory, you will figure out which is a zone. If you go into this zone, it will be broken. So actually, how to do it? In this trajectory, you know, this area is actually a very critical part. So if your trajectory did not go inside into it, then it's a good trajectory. For example, you can do a trajectory like this. This is a good trajectory because it does not enter this zone. But this is not a good trajectory. Even you do something like here, 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 here. Even you do something like this, it's not a good trajectory because it's enter here, it's enter this area. If it's enter to this critical zone, it's give you a fail result. So this is one way to analysis this stuff. You give a lot of sample, and at the end, you will figure out actually there's a critical zone. You should not enter it. If you load data before someone store the data back to your variable, then you will get the bad trajectory. So this is the idea how to detect this critical zone. So why we need to know what's a critical zone? Because we will talk about how to protect it, how to avoid risk condition. And the key is you need to know where is the critical zone. If you understand where is the critical zone, you can use some way to protect the critical zone to make sure you don't have any trajectory go inside, go into this critical zone. So we will talk about the semaphore, how to protect your critical zone in other video. But before you protect it, you should know where, which part, which area of your source code is critical zone. Actually, which is source code in this example, which is the source code for critical zone. The critical zone is here. Before you do anything, before you load in, before you store anything, this is the critical zone. So we need to protect this line of code to avoid the rest condition, to avoid the case you happen here. Okay? So this is for today's video. I hope you got like what's a critical section in your code, and it's not like a so simple because it's also related to the assembly, which we did not cover in these videos or other videos for this class. So you probably like get confused about it, but just keep in mind it's not so simple. So you need to like think a little bit more about like how to protect it and give like a the trajectory or some like a diagram to figure out what's the safe zone to like to process it. It's really important. So you need to find a critical zone. Then you can then you know like where you should protect in your source code. We will talk about how to protect it by using semaphore in other videos. Okay, so I hope you enjoyed today's videos. See you next time. The critical zone is useful.